Okay, well, I am back on the Conrad Johnson MV-60. I did order some parts, as you can see. 4 brand new rectifier diodes. I got two 220 microfarad 35 volt caps. I have a new 4700 microfarad 16 volt, and they're all 105 degree Celsius rated caps, so they're good quality capacitors. I believe that's a Nippon Chemicon. And I think these are Panasonics, but they are 105s. And I went ahead and opted to go ahead and replace the, what are they, 0.15 microfarad 600 volt capacitors with some new 630 volt caps, especially that one that was discolored. So I got to pop the top. Once again, once you pop, you can't stop. Get the tubes out of this thing, make them safe, get the board out, do all the work. So one moment. Okay, so I did choose to replace all 3 of these capacitors on the bottom of the board because they've been running hot. They're 150 nanofarad capacitors. Let me get this flipped up here. And we're going to go ahead and replace both of these electrolytics. They are both 47 microfarads, 160 volts. Verify they're both the same so I don't have to reorder parts. Yes, they are. And just because we're here, I'm going to change these 2 electrolytics over here, 220 at 35. Hopefully I ordered all the correct components. We can make this thing good once again. Remember, the 4 diodes kind of land up under here, and then the capacitor mounts on the other side of the board. So let's get started on this project. Make this thing work great once again. Okay, well, I do believe I have all the parts replaced. And somebody made a comment that these 8 tubes draw more than 6 amps, which is what the diodes are rated at. And I 100% agree. I think they should have used a 25 amp bridge rectifier and just mounted it somewhere else, like over here or on the side. I don't know, just somewhere else, and ran 4 wires to it. Why'd they go this way? Which is the weirdest thing. I did make notes as the direction of the diodes when the board is up like this. So those 2 facing down and those 2 facing left for the cathode. I did go ahead and stand up. You may have noticed these capacitors a little bit because this is a double-sided board, but I do not believe that it is a plate-through board, which means solder integrity on this side is very important, especially when that one trace goes up underneath there. And I think no traces on that one. There was a trace on these one of these little guys over here, but I did opt to leave the capacitors up far enough that I could solder both sides of the board just to have lead integrity, solder integrity, I should say. I did stand these guys up, hopefully to reduce a little bit of heat from the circuit board. Hopefully this one will not turn brown in 3 minutes. So I think all that's left to do is throw a fuse in here, and I'm going to power it up without the tubes first. And I just want to look at the voltage on this capacitor. I do need to put a zip tie around it. One moment, so it doesn't vibrate. And then I do need to reattach the power LED leads to it as well. Okay, that should be good. Just loosely attached. Doesn't have to be super tight. Just keep it from flopping around. And I'm pretty sure that the LED went in that orientation with the positive lead having a dropping resistor. And then this one just wrapped around that one lead. We'll pre-bend it and get it ready. So, like I said, I'm going to mount this board, and I will supply AC power to it, and we'll move forward from there. One moment. Well, like a ding-dong, I put the cap in backwards. I didn't power it up yet, luckily. Okay, well, the board has been removed. The cap has been replaced in the correct direction and remounted. Nothing's touching anything. It is zip tied down nice and tightly. So what I want to do is, this is where I got in trouble last time. I want to supply about 6 volts to this capacitor, which is what the filament voltage needs to be. And so I'm just going to add a little 6-volt power supply here. And I do see the red indicator somewhere over here. There it is. You can see it is lit. If I shut the power supply off, it should dim out. And it does. Power back on. So I guess at this point, we put the tubes back in it, fire it up, see what happens. One moment. Well, I thought to myself, let's go ahead and power this thing up before we put the tubes back in it and just look at this voltage and see what happens. So I'll start ramping the voltage up. I'm not sure if the power switch is on the on mode or off mode. Obviously it's off. Power switch is now on. Oh, I do see a little current draw. Okay. Not sure what that was. Interesting. Not what I was hoping for. With no tubes. Maybe a cap reforming. Well, we're up to nearly full voltage there. We do have a red power LED in the front. 6.4 volts. Interesting. There we got 460 volts on that cap. And 460 volts on that cap. We'll power it down. Measure the voltage again. And it is dropping. I'll put this in the low impedance mode to discharge these things quickly. And they appear to be discharged. Are they in parallel? They must be. I thought there'd be a plus and a minus, but I guess not. Huh. Well, that's odd. Okay. That's common. .7 volts. And 1.6 volts. Okay, well, I guess we put tubes in it. See what it does. One moment. Okie dokie. Tubes are reinserted. Stickers are off the tubes so they don't melt. I'm going to power this thing on. We'll start at low volts and bring it up slowly. I do see current draw. Tubes are warming up. All right, we are back up to full voltage. I do have a power indicator. I'm not seeing any lights in the tubes, however. That's odd. And yes, there are lights in the tubes. And I do have audio. Let's see, we're at 110 volts. All right, we're at 125. I do see the bias adjust lights are on and flickering. It says to bias it after a half hour of warm-up time. Now we have all four, or at least all three lights intermittently blinking. I do have it going into a ding-dong load, a big dummy load. So I'm not driving the speakers directly. Wow, output tubes are barely warm. They're getting there. At 125 volts, this thing is pulling about 200 watts, just idling. And I assume a lot of that is just tube dissipation, heater dissipation. I'm going to take it down to exactly 120 volts, and we're pulling 150 watts right now. Well, I'm going to let it sit here and cook for a while, and we'll see what happens. Okay, so I do have the unit powered up. I do have the red light on the front of it. It is connected to the big ding-dong load back here. I do have my ancient Syncor watt meter hooked up in the 100 watt mode. Now remember, this is going to be RMS power. It does not read peak power. So all I would expect out of this amplifier, being an MV-60, is probably maybe 30 watts per channel peak. It might be 60. I'm not sure what these tubes are actually rated at. We're over here at, we're just under 120 volts AC. I'm going to pump it up to right at 120. We'll put it on the 4 amp scale. That's what we're pulling, just idling right now, just under 200 watts. And I've got an MP3 player connected. It is doing something, that's for sure. Here's the watt meter over here. It's showing 10, 20 watts, RMS power. There it goes, a little over 20 right there. So I'm pretty happy with this. Let's turn this down. So these are attenuated outputs on the dummy load right here. But anyhow, I'm going to say that is it. It's been running for probably 30, 45 minutes. And looks like I do have to rebias 2 of the tubes. They do flicker intermittently depending on the power level. Yeah, there goes that one back there with high power. Anyhow, I'm going to call it a win. So, bunch of capacitors, some diodes. This thing should be refreshed for many, many more years. I certainly hope you enjoyed the video on the Conrad Johnson MV-60. Go ahead and leave me a question, a comment, a concern down below, good or bad. I do try to respond to the comments when I have time. While you're down there, if you could, please hit the subscribe button and like this video. It helps my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, or X at NorCal715. You can email me, norcal715videos@gmail.com. As of right now, the first part of 2026, that is not the best way to contact me. Please leave me a comment in one of the videos. Everyone, thank you for watching. I really, really appreciate it. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you once again for making it to the end of this video. I really, really appreciate it. Everyone, have a great day. Once again, thanks so much for watching. Bye-bye. And I did rebias it. Everything's working great right now. It only actually lights the bias indicators on the peaks. So on the valleys, the bias is out. So if I mute this, then the bias is out. That's where it tells you to set it after a 1/2 hour warm-up. All right, everyone, thank you again for watching. I really, really appreciate it. Have a great day. Bye-bye. All right, well, I'm pushing this thing about as far as it'll go. Over here on the current meter, I have to put it up on the 4 amp scale. Definitely working like it should. Remember, this is RMS output. It's not peak output, so the peaks might be 50, 60, 70 watts. MV-60, I'm thinking maybe 60 watts per channel or 60 watts total. Anyhow, it is working. Let's do that over. All right, here we go. Audio sync. Cell phone is recording. 1, 2, 3. Check, check, check. All right.